So let's look at a following AI, one that follows the character. Now, this is actually going to be pretty easy since the way we set up the Wanderer was that the Wanderer went to a target. And so most of the machinery we already have here. Exposed variables, I've got, again, this inner circle. I've got one common flaw of AIs is that they come right to the player and they bump up against them. And so instead, I'm going to have this distance in front of the player. Their target is the player, but it's offset some distance in front of the player so that when the AI reaches the player, instead of bumping up against them, it stands out in front of them where you can see them, and that makes life a bit easier. So the start function, we're going to get our animator. With AIs, it's often good to give them a bit of randomness, and I'll do this by setting the animator's speed. This is not the speed parameter that controls the state transition. Animator.speed is how fast all the animation clips play. So this will make each AI move at a different rate. Their animations will still play exactly as they're supposed to, but their rate will go from 0.6 to 1.4 times their normal speed. If I don't have a target in my exposed variable, I'll find the player by tag. Otherwise, I'll use whatever target was in the exposed variable. And I'm going to start my while loop this time with a start coroutine seek. Seek takes the place of idle here. Start is a coroutine. It has type I enumerator, and that allows us to use the yield that is going to yield this. The seek function looks a lot like idle. We have the position that is the target position plus the target's forward vector scaled by the distance in front. So the position that we're seeking here is going to be out here in front of my player. The target is the player, target forward is the vector out the front of the player, and we're setting the position to be that point out in front of the player. If distance is outside the inner circle, we're going to turn the speed to 1, set the speed to 1. We'll calculate current direction and wanted direction the same way we did with idle. We'll do the dot product just like we did with the idle or with the wander script. And we'll do the cross product to get the direction, again, setting it to the Y component if we're facing the player, and to plus or minus 1 if we're facing away, again, clamping it plus or minus 1 and setting its direction. Otherwise, we're facing away. Otherwise, we've reached our player. If the distance is less than the inner circle, then we've reached our player. So I'll set the speed to 0 and return null, and that ends the coroutine. So that looks like this. Follow. So there's my little character out there. He wants to be some distance in front of me. He's happy with that spot. If I move, he then chases after the green bubble, which incidentally is just a thing up in the sky above my character. And he's very happy to stay right in front of me. How rigorously you make him stay in front of you would be how big you set that inner radius. Okay, so we've got a wanderer and a follower. Fleeing is fleeing is really quite trivial. It differs only from seeking in that the distance test against the inner circle is reversed. In other words, if we're too close, then we flee. And we reverse the sense of the wanted direction. So the wanted direction is now a minus sign. The speed is now, if we're inside the inner circle, we want to flee. But those are the only changes we make, and we can set it up exactly the same way. And now my little character, I should leave this running so that I don't have to start it every time. When we flee, there's the inner circle is that green bubble. If I move close enough, he starts to run away, and he'll run until he's outside the inner circle. As long as he's inside the inner circle, he's not very happy, and I can chase him around the world. I'll leave that running since we'll come back to it. So we have wander, we have follow, we have flee mechanisms.